Welcome back, guys, to my YouTube channel. Today we are going to be doing a problem solving question, sort of, whereby we are supposed to find the value of sine theta um, using a diagram. So now what I want you to recognize is that this 2 sine theta, well, the 2 sine theta cos theta is the same thing as sine of 2 theta, right? And then so basically I have sine 2 theta is equals to 2 root 6 over 5. And then over here I've been given 45 degrees, or theta is between 45 degrees and 9 degrees, which means that theta lies in the first quadrant, right? But then what I'm gonna do is that I am going to draw a diagram using this angle 2 theta, and then from that diagram, some way somehow I am going to get that sine theta using the double angle formulas. So now I'll just show you how I'm going to do that. So now, for you to order to draw a diagram, you need to have 2 bits of information about an angle. So here you see that we are going to sketch our diagram using 2 theta. So what information do we have? We have that sine 2 theta is equals to 2 root 6 over 5. So basically, you had the sine of a certain angle. Let's just take this whole of 2 theta as a single angle. So you had the sine 2 theta, this angle 2 theta, and it gave you a positive. So where is sine positive? So if you check your diagram like this, where you have all students take a coffee, you see that sine theta is positive in the first and the second quadrant, which means that 2 theta, it's either going to be in the first quadrant or it's going to be in the second quadrant, right? So that's what we have. So now what I'm just going to do is that I'm going to do a tick on this quadrant, and I'm going to do a tick on this other quadrant. That's one bit of information which you have. And the other bit of information is that 45 or theta lies between 45 degrees and 9 degrees. So what we can see is that this implies that if you multiply by 2 throughout, you're going to get 90 degrees less than 2 theta less than 180 degrees. So I multiplied by 2 here, multiplied by 2 here, multiplied by 2 here, then I get this, which tells me that that angle 2 theta lies between 90 degrees and 180 degrees, which is a tick on this side. So now that I have a tick on that side, which means that now I can conclude that my 2 theta is in fact in the second quadrant, because what I saw is that on that first condition of the positivity, I was getting 2 quadrants, either the first or the second. But this second bit of information confirms to me that it's indeed the second quadrant. So when you draw your diagram, it's going to be like this. Then you're going to have something in the second quadrant like that. Then you're going to go like this, and then this is your 2 theta. And then what you're going to see is that sine theta is opposite over hypotenuse, right? Or y over r. So the opposite side, let's just pretend as if this theta is in here, just to help you visualize things like that. But it's not really in here. It's just 2 theta is from here up until then. But then basically what you're going to say is sine 2 theta is going to be opposite over the hypotenuse. Opposite over the hypotenuse, which means that here we have 2 root 6, which is our opposite, and here we have 5, which is our hypotenuse. And then so now if we use Pythagoras, we can then find our x, right? So we're going to say r squared equals to x squared plus y squared, using what? Pythagoras. So our r, we saw it's 5, and then our x is what we're looking for, and then our y is 2 root 6 all squared. So you're going to get 25 x squared. You're going to get 4 into 6, right? And then you're going to get this is 24. That means that x squared is equals to 1. And x is going to be plus or minus 1, the square root of 1. Or x equals to plus or minus 1. But because x is going to be plotted here, which is where it is negative, therefore x is going to be equals to -1. And then so now here we have -1. So now what am I going to do? I'm going to use the double angle formula for cos. So remember that cos has three things. So you have cos 2 theta equals to 2 cos squared theta minus 1. Then you have cos 2 theta equals to 1 minus 2 sine squared theta. So we are going to use this property to our advantage. So basically what I'm going to do is that I have my 2 theta here, or my 2 theta here, and then the cos of 2 theta is going to be my adjacent over my hypotenuse, right? Which tells me that, okay, let's continue with our question. Cos 2 theta is going to be equals to -1/5. And you know that cos 2 theta is equals to what? 1 minus 2 sine squared theta is -1/5. And then we're going to simplify. So we take 1/5 to this side. We take -2 sine squared theta to the other side. And then over here, we're going to get 6/5. Then you're going to get 2 sine squared theta. We multiply by 1/2 on both sides. Then we get sine squared theta is equals to, here we're left with a 3/5, right? And then which tells us that our sine theta is going to be equals to plus or minus the square root of 3/5. But then what we know is that theta is between 45 degrees and 90 degrees. If you visualize this on a diagram, basically you have 45 degrees here, and then you have your 90 degrees here. So what they are saying is that theta lies somewhere along this part. So theta could be this, it could be that, it could be that, right? So it lies between 45 and 90 degrees, but which is still the first quadrant. And what is the sign in the first quadrant? It's positive, right? So therefore here, because theta lies between 45 and 90 degrees, which is the first quadrant, therefore sine theta is just only going to be equal to the positive square root of 3/5. And with that, I thank you, my kind people. Don't forget to like, share, and subscribe.